From space, the Earth's surface is seen as peaceful groupings of land and water. But inside the Earth, it is turbulent and hot. Below the Earth's crust lie layers of molten rock called magma, and at the Earth's core, temperatures can be as hot as 9,000 degrees Fahrenheit. In this lesson, you will learn how this natural heat can be pulled to the surface and used to heat buildings and produce electricity, as well as the pros and cons of this energy source. Geothermal energy is defined as heat from within the Earth that can be used for heating or to generate electricity. This is an easy term to recall if you remember that the prefix geo means earth, and the word thermal means heat. So geothermal literally means Earth's heat. As we mentioned, there are extreme amounts of heat found at the core of the Earth. In fact, this intense heat is enough to melt rocks, resulting in magma. Magma that reaches the Earth's surface through cracks in the Earth's crust is known as lava. However, magma does not always come to the surface of the Earth. If it stays trapped within the layers of the Earth, it can heat underground water. It can form natural pools of heated water, known as hot springs, or gushing jets of hot water and steam that burst up from the Earth's surface, known as geysers. If the heated water within the Earth does not reach the Earth's surface, it remains as underground concentrations of hot water and steam, known as geothermal reservoirs. By tapping into geothermal reservoirs, we can efficiently heat our homes and businesses and even generate electricity. Let's take a look at how this is done. Geothermal heat pumps, also known as ground source heat pumps, are systems that use the stable temperature of the Earth to heat and cool buildings. A few feet below the surface of the Earth, the temperature stays at about 50 degrees Fahrenheit year-round. Geothermal heat pumps rely on this relatively constant temperature to both heat and cool buildings. Water and other fluids are circulated through a loop of buried pipes. In the winter, heat from the ground is pulled into the building and circulated through a duct system. In the summer, the process is reversed. The building's heat is picked up by the circulating fluids within the pipes and transferred into the earth, helping to cool the building. Geothermal heat pumps show how geothermal energy can be used for heating, but it can also be used to generate electricity. Geothermal power plants are facilities that convert the Earth's natural heat into electricity. These plants drill wells into geothermal reservoirs to bring hot water and steam from deep within the Earth to the surface. All geothermal power plants use steam to spin turbines attached to electricity generators. However, there are three different types of geothermal power plants. The one selected for an area will depend on the temperature and pressure of the available geothermal reservoir. A dry steam plant directly uses steam to spin a turbine. These systems use very little water, hence the name dry. This is the oldest and least complex of the three designs, but because this is an open system, it can release hazardous substances such as hydrogen sulfide into the atmosphere. A flash steam plant moves high-pressure geothermal water into low-pressure tanks to produce a flash of steam to spin a turbine. After the steam is used, it is cooled and condensed back into water and injected back down to the reservoir. A binary cycle plant uses geothermal water to heat a secondary fluid that spins a turbine. You can recall this term by remembering that binary refers to two components. A binary cycle plant relies on the cycling of two fluids, the hot water and a secondary fluid. The advantage of a binary cycle plant is that lower temperature geothermal water can be used to generate electricity. With this system, moderately hot water is passed through a heat exchanger where it heats a secondary liquid that has a lower boiling point than water. This fluid then flashes to vapor to spin the turbine. There are many advantages to geothermal energy. Geothermal energy is renewable energy because once water or steam is used, it can be pumped back into the ground. It is also clean energy. Geothermal power plants, unlike plants that burn fossil fuels, do not produce greenhouse gases that can be harmful to the atmosphere. Geothermal energy is easy on the local environment because the power plants do not require the clearing of large areas of land, damming of rivers, or mining like other energy sources. It is inexpensive to use. Once a geothermal system is installed, the source of energy is free to use, and because the plants use very few moving parts, there are generally low maintenance costs involved. It also reduces a country's dependence on imported oil, which can be unpredictable. Now, even though there are many advantages, there are also some disadvantages to geothermal energy. There is an initial cost barrier that comes with researching appropriate areas, building the power plant, and drilling into the earth. Also, because this energy source is not yet widespread, there's a lack of equipment and qualified staff that adds to the initial costs. Geothermal energy requires a suitable location. The location of a geothermal power plant must be in an area with sufficient geothermal activity at a depth that is shallow enough for easy drilling. Reservoirs can run out of steam. While the cause is not always known, this can result if temperatures drop or too much cooled water is injected back into the reservoir. Even though geothermal energy generation does not produce pollutants, there is the potential danger of hazardous substances being released. During the drilling process, gases and minerals can escape that can be hazardous to the environment. Also, geothermal energy is not easily transported and is therefore only suited for local energy and heat generation. Let's review. Geothermal energy is heat from within the earth that can be used for heating or to generate electricity. We can tap into geothermal reservoirs, which are underground concentrations of hot water and steam, for use in heating and electricity generation.